The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It supports us as we embark on an excursion through space to uncover and discover Proxima B's secrets, and whether it could be the next Earth. We ought to take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star. The planet Proxima Centauri is more than just any ordinary rock. It's real. See, Proxima B is found a mere 4.2 light-years from us. This planet is covered in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Aside from that, Proxima Centauri B isn't alone in that system around the red dwarf star. It has a companion, Proxima Centauri C, and who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri's energy production is roughly the same as Earth's from its star's energy, from the Sun. Could this truly mean that there's water on its surface, and perhaps even life? As we venture outside of our solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like wandering travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet, with a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly sprayed by the Sun, while the opposing side will always be in darkness. Let's look at Proxima Centauri, the star that Proxima B orbits. The Alpha Centauri system includes Proxima Centauri. This system includes Rigel, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars, Rigel and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf, or M-type star, found 21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima in fact means the closest in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our nearest neighbor in space, Proxima is not visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs, like Proxima Centauri, for example, are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for an additional 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still up for debate. One argument is that it is a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. But it's not as comfortable to live in as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, frequently more powerful than the radiation we get from our Sun. That's right, it's so extreme that even the lightest particles of hydrogen are removed, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and keeping a water-friendly surface. Without it, living organisms would be susceptible to harsh space weather conditions, making life nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are many factors that render it inhospitable. The mission to reveal the truth about Proxima B continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally slated to launch in 2021 and will assist us in determining if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to make sure that the James Webb Telescope could capture accurate images. As Abby Taber, a theoretical physicist at Harvard, explains, if a planet like Proxima B can, besides being able to absorb light from its star, transform it into infrared light, The James Webb Telescope was specifically designed to detect infrared light and can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere does not guarantee that life exists, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is significantly denser than Earth's and extreme temperatures that would make it impossible for life to exist. The journey to decipher Proxima B's mysteries is not without its challenges. While the James Webb Telescope holds promise, there are additional aspects of cost to take into account, increasing pressure from space scientists, and the pressure to find ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so captivating, almost like more of our backyard. Exploration is exciting, as it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions as technology advances. It's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima along with it. This solar pressure is used by technology to keep the spacecraft on course, eliminating the issue of running out of gas. These hot Jupiters present an incredible spectacle. Their orbits are so close to their stars that they experience extreme heat, making them some of the most hostile environments known to science. The blistering temperatures can cause their atmospheres to stretch out, creating dramatic weather patterns, with violent winds and massive storms. Imagine a planet where the very air itself is shaped by the intense gravitational pull of its star, a place where the weather is as unpredictable and extreme as anything we've seen here on Earth. As we study these worlds, we're constantly amazed by the diversity of planets that exist beyond our solar system. Some are rocky, some are gaseous, some are molten, and others are frozen. Each new discovery adds another layer to our understanding of the universe, pushing the boundaries of what we thought was possible. It's a reminder that the universe is a vast, dynamic place, teeming with planets that could one day hold the key to understanding more about the origins of life, the nature of existence, and the future of humanity. While we are still far from being able to visit many of these exoplanets, technology is advancing rapidly. The James Webb Space Telescope is just one of many tools that will help us unlock the secrets of these distant worlds. With future missions planned to explore these faraway planets, we could one day answer the question that has captivated humankind for centuries: are we alone in the universe? Until that time comes, we continue to dream, to look to the stars, and to explore the vast, uncharted territories of space. Each new discovery, whether it's a rocky exoplanet like Proxima B or a gas giant hurtling through space, brings us one step closer to understanding our place in the cosmos. And who knows? Perhaps one day, our descendants will walk on a planet like Proxima B, looking out at the stars with the same sense of wonder and excitement that we feel today. In the end, the search for life beyond Earth isn't just about finding other civilizations or planets that might support life. It's about exploring the unknown, expanding our horizons, and pushing the limits of human curiosity. It's a journey that has just begun, and it promises to be one of the most exciting chapters in the history of human exploration. As we continue to gaze at the stars, the mysteries of the universe remain tantalizingly out of reach, but with each new discovery, we're getting closer to unraveling the secrets that lie beyond our world. And so, the adventure continues, with Proxima B standing as one of the most intriguing destinations in the search for life beyond Earth. The future of space exploration is bright, and the possibilities are limitless. The universe is waiting for us to discover its secrets, and we are only just beginning to scratch the surface. Whether it's the pursuit of knowledge, the hope of discovering extraterrestrial life, or the desire to explore the cosmos, the quest for answers will inspire generations to come. The journey may be long, but the rewards, knowledge, discovery, and perhaps even a new home for humanity, are worth the effort. And extreme heat, in addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in clouds, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. It orbits in the habitable zone of its host star, and scientists are currently investigating whether it could be capable of supporting life. Proxima Centauri b is of particular interest because it is the closest potentially habitable planet to our own solar system. As we continue to explore these fascinating worlds, the James Webb Telescope promises to provide even more insight into their potential for life and habitability. The allure of Proxima Centauri lies not only in its proximity but also in the tantalizing possibility that it may harbor conditions conducive to life. As we probe deeper into the exoplanet's characteristics, the question on every scientist's mind is whether Proxima holds the keys to understanding whether life can exist beyond Earth. While it may be a rocky world, its orbital position within the habitable zone and its potential water presence make it an exciting target for future exploration. However, there's a catch. The proximity of Proxima Centauri b to its star means that it could be subject to dangerous radiation, especially given that red dwarf stars, like Proxima Centauri, are known for their violent flares. These flares, which emit intense bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to take root. Proxima may also face tidal locking, a condition where one side of the planet is permanently facing the star while the other side remains in darkness. This could lead to extreme temperature differences between the two sides, complicating the conditions needed to support life. Yet, there are still many uncertainties. We do not fully understand how the planet's atmosphere interacts with its environment. For example, could Proxima b possess a protective magnetic field that could shield it from the star's radiation? This would be crucial for sustaining life on the planet. Similarly, the possibility that life, if it exists on Proxima b, could have adapted to the harsh environment cannot be ruled out. Life on Earth, after all, has managed to thrive in even the most extreme conditions, from the depths of the ocean to the frozen tundra. Could Proxima b offer a different form of life, one that thrives in the face of challenges we cannot even yet imagine? In addition to these considerations, Proxima b's proximity to Earth makes it a prime candidate for interstellar travel, especially with future advancements in space technology. While our current spacecraft, like Voyager 2, would take tens of thousands of years to reach the system, more ambitious projects are being proposed. Solar sail technology, for example, offers a potential solution. Using the pressure exerted by sunlight, solar sails could propel spacecraft at a significant fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore distant exoplanets like Proxima Centauri b. The potential to one day send humans to Proxima b is an even more tantalizing possibility. While this prospect remains far off, it fuels our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima b's atmosphere, study its surface, and gather essential data to help us determine whether it can support life. Through its infrared capabilities, Webb can provide us with invaluable insight into the planet's weather patterns, composition, and more, bringing us closer to understanding whether Proxima b could one day be a second home for humanity. As we move forward, it's clear that exploring exoplanets like Proxima b offers more than just the chance to find alien life. It also represents our desire to understand the universe and our place within it. Each discovery, each piece of the puzzle, brings us one step closer to answering fundamental questions about life, the cosmos, and what the future holds for humanity. Whether Proxima b proves to be habitable or not, the journey of exploration will continue to inspire and shape our future. As we continue to explore the mysteries of distant worlds, our pursuit of knowledge brings us closer to understanding not only the vastness of the universe but also the potential for life beyond Earth. Every new discovery, every exoplanet found in the habitable zone, sparks new questions and new possibilities. The technology we develop to study these distant planets, like the James Webb Space Telescope, helps bridge the gap between what we know and what we have yet to discover. The idea that life could exist on another planet, even under conditions vastly different from our own, is both humbling and awe-inspiring. It challenges our perceptions of life and pushes us to reconsider what it means to be alive. Could there be forms of life on Proxima B that do not rely on water as we do? Could life thrive in ways we cannot yet comprehend? These are questions that may only be answered through continued exploration, innovation, and dedication. Moreover, the search for exoplanets also speaks to something deeper within us as humans. Our desire to explore, to seek out new frontiers, and to push the boundaries of what we know is a defining aspect of our nature. Whether it's the discovery of a potentially habitable planet like Proxima B, the advancement of space travel, or the quest to understand the fundamental laws of the universe, these efforts reflect our innate curiosity and our drive to find our place in the cosmos. In the coming decades, as our technology continues to evolve, we may discover even more Earth-like exoplanets, some potentially even closer to us than Proxima B. This expanding knowledge could open up new pathways for humanity's future, whether through technological advancements that allow us to travel to these distant worlds or through new ways of understanding how life might survive and thrive in extreme conditions. The exploration of exoplanets also highlights the importance of international collaboration. Scientists from around the world are working together, sharing their expertise and resources to solve the complex puzzle of how life might exist elsewhere in the universe. This cooperation is crucial not only for the advancement of space exploration but also for fostering a sense of global unity, as we all share the same home, Earth. As we look to the future, we can only imagine the discoveries that await us. Will we find evidence of life on Proxima B? Or will it be another world entirely that surprises us with its potential to host life? Whatever the outcome, the journey of exploration will continue to inspire generations to come. And in the end, it is the pursuit of knowledge itself, the desire to understand the universe and our place within it, that will continue to propel us forward into the unknown.